Good morning, my name is Nicole Suarez and I'm the reporter for group number 2, experiment 2, the bomb calorimeter. So this is an overview of what we're gonna talk today, background, objectives, the important equations, the apparatus, the raw temperature data, the analysis, and the conclusion. So a background, what is a bomb calorimeter? A bomb calorimeter is used to determine the heat of combustion by igniting a sample in an oxygen bomb and measuring the resultant rise in temperature in the surrounding water. What is a calorie? A calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 Celsius. 1 big C calorie equals to 1 kilocalorie, which is 1,000 calories, and that's equal to 4,184 joules. What is the objective of this lab? To become more familiar with the physical principles, procedures, and analysis techniques associated with the oxygen bomb calorimeter, determine the thermal capacitance of the calorimeter, and determine the gross heat of combustion of the sample provided. We only use one equation, which is Q equals mCV times the change in temperature, where Q is the heat of combustion of the known fuel and the ignition wire. MCV is the thermal capacitance of the calorimeter, and delta T is the different rise in temperature. This is the apparatus that we use. The first picture there, it's like the complete whole setup with the bomb inside already. And this one is close up to the bomb. This one is the ignition wire, and this is where we place the sample. And the first sample was the benzoic acid. Then we do the water jacket preparation, so we add 2 kilograms of water to the bucket. We place the bucket into the calorimeter, and we start with the instrumentation preparation. And then we do the bomb preparation. So we measure and cut 10 centimeters of nichrome ignition wire. We place 1 gram of benzoic acid into the crucible, and it cannot be more than 1.1 gram. We connect the connection wires, and they have to touch the benzoic acid, and we add 1 milliliter of water to the bottom of the bomb, seal the bomb, pressurize, and depressurize it. So this is the first graph that we got. We start getting the data. We waited for 2 minutes, and then we press the red button in the ignition unit to ignite the fuel in the bomb. That's why we can look like a constant temperature, and then it goes up when we press the bottom until it reaches again constant temperature. I measured the time for around 4 minutes to 40 seconds because we had to wait 2 minutes and then at least 2 more minutes till the temperature got constant again. And then for the gummy bear, it was almost the same. We waited for 2 minutes. We pressed the button to ignite the fuel in the bomb, and then it became constant again. And this is how we calculate the data. So we use the ignition wire, 10 centimeters equals 23 calories. For the benzoic acid, we use 0.98 grams of benzoic acid. And what was left from the wire after the procedure, it was 7 calories of wire, and the difference in temperature was 2.5. And for the gummy bear, we used 1.08 grams, and the wire left was 6.1 calories. And the difference in temperature was 1.4. So we find the thermal capacitance of the calorimeter using the benzoic acid. We use the formula mCV equals Q over delta T. I found the Q multiplying the grams. I convert everything to calories. I multiply the grams times 6,318 calories per gram. And then the 304 centimeters, that was the length of the burned wire left. And I multiplied that times 2.3 calories per centimeter to get my Q in calories. And then I divided by the change in temperature, which was 2.5. With the same CV, we have to calculate Q for the unknown sample, which was the gummy bear. I multiply MCV times the change in temperature of the gummy bear, which was 1.4, minus the burned wire calories, which was what was left. which was 6.1 calories, and I divide that by the grams of the gummy bear, which was 1.08. And my answer was in calories per gram. This is a comparison of like, I also searched for different fuels, methane, petrol, and gas, and they have higher heat of combustion values than the gummy bear and the benzoic acid. And even though the benzoic acid has higher amount of combustion than the gummy bear. And that was the whole experiment. So as a conclusion, I can say that higher heat of combustion will give us a higher delta T. Both of them are proportional to each other. And in our case, MCV was constant. We use it for both equations. And possible errors can be, there can be uncertainties in the scale to measure the fuel. Or also the ignition wires, after the procedure, we measured them and they were not completely straight. So we don't know if that's like the whole length of the wires, and then possibly uncertainty of heat loss. That's it. Thank you so much. Yes.
On the slide with the chart, did you find that, what is that, 3,900 calories per gram? Where did you get that value?
So, okay, so like I was struggling with that. So I got like a package of gummy bears and I saw the amount of calories that it was in the bag, and it was like 3,300 something calories, but then I multiplied that times 1,000, which that was calories, and then I divided by the number of grams that it says in the package. So it's an approximate, maybe it's wrong, I don't know,
yeah,
but that's...
I didn't know if you actually went and found something.
No, that's how I did it, maybe it's wrong.
Yeah, that's good.
So. Yeah, more questions?